Good day, everyone. Good evening if you're watching this at night. We are Group 1 of Soil in Engineering Chemistry ED2. Uh, and we are here to present our project on terms of development of soil chemistry in agriculture in terms of irrigation development with the use of hydrophilic polymers. Before we get started, we would like to introduce ourselves.
Hi, I'm Claudine Camacho from MEM 119.
Hi, I'm Chen Therese from MEM BME 119.
Hi, I'm Joseph Francisco from IME 119.
Hi, I am Romel Lalik from CPE 118.
And I am Vince Mahinan, ID 119MEM MR. So to give you a background of our project, uh, we know that land is almost everywhere, but at the same time, it's also limited. There are a lot of people using it, a lot of animals also taking part. We also have to keep our forests safe and at the same time sustain development of our ever demanding lifestyle as humans. So with this in mind, we aim to harness the full potential of soils. We have to make it sustainable, healthy, and safe in order to have continuous development in terms of food, to feed the generations now and the generations to come, to sustain the needs of the animals as well, and to keep biodiversity at its best. We also do not want to waste any more rainforests as we deeply need plants to absorb our carbon dioxide emissions. And with that, we have devised a machine to both identify the health of the soil and integrate it with irrigation system so that we can produce better and more efficient.
So there are problems that provoke them to make this device. So the first problem that they see is that the Philippines has been experiencing severe drought triggered by El Nino every year, causing the loss of agriculture production amounting to 82 million US dollars. The drought affected water supplies and the livelihoods of several towns in the Philippines. The second problem, according to the Food and Agricultural Organization of the United Nations, harvested crops remove nitrogen, phosphorus, and other nutrients from the agricultural soils. Hence, sustaining agricultural production requires replacement of the nutrients, whether through biological processes like nitrogen fixation or through the addition of animal wastes or mineral fertilizer to fields. The last but not the least problem that the group sees is that the soil degradation is a severe global problem of modern times. Soil degradation is defined as the process which lowers the current or future capacity of the soil to produce goods or services. It implies a long-term decline in soil productivity and its environment moderating capacity. Soil erosion is the most widespread process of soil degradation and is also the most studied in the country. Other important but less studied soil degradation processes include loss of nutrients and organic matter, salinization, acidification, pollution, compaction, and subsidence. So, I'll be stating some of the advantages of using our device. The first advantage, the irrigation system distributes a water containing nutrients. With the advancement in irrigation technology, there was an increased percentage of water efficiency. And also, it will improve the quality of soil and food crops. Second one will be our induced machine will monitor the soil nutrients and ensure the proper levels of its nutrients are being observed. Third but not the least, advantage that they see is that the efficient farming. The farming techniques are gradually adapting to automated systems which offer a controlled application of nutrients and fertilization. The group hypothesis is if our device is produced and used effectively, then we can alleviate the harsh effects to drought seasons across the country, making easier for farmers to produce goods for us to consume.
So for the objectives, we have three. Our first objective is to identify soil health in cooperation with the irrigation system to make a seamless process possible. Second would be we should lessen the waste that we are producing by optimizing the exact amount that the land needs with the help of technology. Uh, Third would be to incorporate the use of hydrophilic polymers in irrigation. So for the significance of the project, we have soil chemistry. So let's start out with what is soil chemistry first. It is the branch of soil science that deals with the chemical composition and chemical properties in chemical reactions of soil. It focuses on the reactions in the soil that could affect plant growth and nutrition. This helps harness the full potential of the land and to realize what treatment the soil needs in terms of nutrition and etc. For the society, this would help society in a manner of cost and produce. With the machine being able to detect what treatment the soil needs, this would avoid further damage on crops that would result to a costly incident. It would also result to a healthier vegetation and less famines occurring in the land, which almost all farmers are trying to avoid. For producers, this would help producers minimize the use of resources and maximizing the efficiency of their processes.
Okay, so there are different types of irrigation systems that are available in the market. But for our device, the subsurface drip irrigation will be the best option to go for the nutrients. The reason behind it is these nutrients will be distributed for each individual crop because it should be concentrated with the provided sensors to determine the plant status. Subsurface drip irrigation is better than the typical surface drip irrigation for the reason that the increase in yield and water savings that was observed from a study from ASEL is 20% better overall with this new irrigation method, which is from the word subsurface uses buried drip tubes to meet the crop below, eliminating all of the water being evaporated while in the process of a normal drip irrigation. So for our power source, we will use solar energy because solar energy is one of the ways to produce energy for farms as well as an easier way for them to acquire the energy needed for different systems to work as direct sunlight because it is a necessity for a place like a farm. Thus, having sufficient sunlight will benefit the solar panels that are planted into the roofs of large farms without the hindrance of nearby trees and city buildings. So access to electricity is not always guaranteed, especially in rural areas. Thus, securing a widely known alternative power source like solar energy will benefit the farmers. The solar panels will then generate electricity that goes through the distribution system and storage tank for irrigation. So the pumps that are used for transporting water directly to the crop roots with the use of drip irrigation systems are equipped with solar cells that will convert the sunlight energy into electricity with a generator that will be used to run the system compared to the traditional use of diesel engines and power grids. So one new approach is the use of hydrophilic polymers as carriers of plant nutrients. These polymers may be generally classified as natural polymers derived from polysaccharides. Number two, semi-synthetic polymers. And number three, synthetic polymers. So by controlling their reaction conditions when forming the polymers, various degrees of cross-linking, anionic charge, and cationic charge can be added, thereby changing the effectiveness as fertilizer carriers. When fertilizer-containing solutions are mixed with hydrophilic polymers to form a gel prior to application in the soil, the release of soluble nutrients can be substantially delayed compared with soluble fertilizer alone. So the effectiveness of a specific controlled release polymeric system is determined in part by its specific chemical and physical properties, its biodegradation rate, and fertilizer source use. Okay.
Next, how does this work? It will all start from a water source. Then the water is being transported via the main pipe and controlled by the main machine. The main pipe will eventually branch out into drip lines that will supply the needed water for the plants. Every yard of a drip line incorporates a sensor that is designed to detect the soil nutrients. This sensor will be administered or injected into the soil to monitor the levels of specific elements such as nitrogen, phosphorus, and potassium for efficient plant growth and for soil fertility. Moreover, the sensor, specifically an electrochemical sensor, is being used in the said system since it consists of an ion selective membrane which selectively responds to a target ion and an electrode which acts as the transducer element. The ion selective membrane can react with nitrogen, phosphorus, and potassium. This can be supported by ion selective electrode, which detects soil nitrate, ammonium, and potassium. When the ions react with the electrodes, it produces an electrochemical reaction, either an oxidation or reduction, and eventually results in flow of electrons. This flow or electrical signal is being detected and amplified into the main machine. For the main machine, it serves as the main controller. It can monitor the levels of soil nutrients, water content, and amount of water being supplied by the drip irrigation. Also, it has modes where it can distribute either water containing nutrients or just water. If the soil lacks some nutrients, then hydrophilic gel that carries plant nutrients is being mixed into the water, then irrigated. Thus, this project, a drip irrigation which incorporates soil nutrient sensor, also promotes precision farming. Wala na akong masabi dyan, Drew.
To give you an idea of everything that was just said, here are some of the sensors to be used. The one to the left would be to sense. But these are basic sensors of nutrient for the soil, and I'm not. Uh, Here is how the working principle of the machine, as stated earlier, was planned to work, where there is sensors attached to the ground and water around. The only one lacking in the bottom picture would be the solar panels, but then that is what we would be incorporating in our proposed design. Uh, Here is the concept that we were trying to incorporate, wherein, as you can see, the pipes here will be the drip irrigation, and whilst here is a solar panel that will be providing for our energy source, and here will be the water, and where the polymers and water itself will be working hand in hand in order to make sure that these crops will be as healthy as possible in order to prevent any more droughts and any other problems when it comes to the soil. And with that,
This project aims to help the target audience, such as farmers, vegetarians, and investors searching for references that are somehow related to our chosen topic.
we would like to say thank you for listening and watching our presentation, and we are here to tell you guys to stay safe and to stay innovative.
Thank you.